is we're going to need to do a little bit of rewriting first. It doesn't look like it's something that's in a quadratic equation form, but it is, because we have something squared, then something to the first, and then something with just a number, and then it equals 0. The problem is that we're not used to seeing fractions as our exponents. But remember, as a reminder, if you have something like an x to the 1/3, is that, remember, it can be rewritten as a root. What kind of root? Whatever's on the bottom. So the 3 on the bottom would tell you you've got a cube root of just x. And the reason why it's just an x is because it's x to the first power. So here's the idea. So we're going to rewrite this original equation. And we're going to rewrite, we've got x plus 5 to the 2/3 plus x plus 5 to the 1/3 minus 20 equals 0. So the first thing that we'll start off by doing is rewriting, because both of these have a 3 on the denominator, is rewriting them as cube roots. So this will look like a cube root of what we had there, which is x plus 5. Notice the x plus 5 was squared, plus the second piece also has a cube root too. It's a cube root of just a regular x plus 5 minus 20 equals 0. So the idea is we can still do what we were just doing. We want to factor. It's going to look a little bit more bizarre, but it's going to work the exact same way. So what are we multiplying by itself and getting 2 of? Well, we're multiplying 2 of these middle pieces, the cube root of x plus 5. Well, if I multiply 2 of those together, it will be the same as being squared. That's why this whole thing will work. So what I'm going to start off by doing is, in my first slot, starting out with the cube root of x plus 5. Perfect. Then I need 2 factors of negative 20 that are going to add up to a positive 1. Well, what 2 factors of negative 20 add up to a positive 1? Well, that's a positive 5 and a negative 4. Well, now that it's factored, what do you always do next? Once it's factored, you set both pieces equal to 0. So we can take the cube root of x plus 5 minus 4 equals 0, and the cube root of x plus 5 plus 5 equals 0. Those will be our 2 equations. Well, in the first one, we're going to get the cube root by itself by adding 4 to both sides. So what that'll do is give us now the cube root of x plus 5 equals 4. So how do I get rid of a cube root? Well, we'll do the opposite. We'll cube both sides. So that will get rid of our cube root with a cube and leave us with what was underneath, the x plus 5. And on the right-hand side, we've got a 4 cubed, which is 64. Then continuing along, we'll just go ahead and keep solving as you would normally. We will go ahead and subtract 5 from both sides, which will give us that x equals 59. Notice I'm not checking my answers here, and the reason why I'm not checking my answers is because I was doing an even exponent to both sides. I was not doing an even exponent to both sides. I was not squaring both sides. I was doing an odd exponent. I was cubing both sides. So I wasn't really worried about false solutions. So one of my answers right off the bat that I've just gotten that I do not need to worry about checking, but you can, is x equals 59. Now let's take a look at the second equation. So the next one, we're going to start off the same way by subtracting 5 from both sides. And what that will now give us is that the cube root of x plus 5 equals negative 5. And then we will cube both sides of the equation. Notice that cubing we'll get rid of the cube root and leave us with what was underneath, the x plus 5 equals, now on the right-hand side we have negative 5 cubed, which is negative 5 times negative 5 times negative 5, which is negative 125. Last step would be to go ahead and move the 5 over to get the x by itself. We'll subtract 5 from both sides, which will get us that x equals 130. So that's our second answer, and we're done. You can check those, but you don't need to because we were dealing with odd exponents, not even. The real time that you need to check things is when you have an even exponent, not an odd.